Hi, I'm Radhika Garg. I'm an assistant professor at the I School of Syracuse University. During this presentation, I will highlight the main findings of our CAI paper that illustrates children's and parents' design ideas for conversational technologies for children's in-home learning. Recent literature has highlighted that children are successfully able to use conversational agents such as smart speakers for various purposes, including searching information, for functional reasons, and for entertainment. We were interested to understand how children would like to devise conversational agents for in home learning purposes because searching information, one of the most popular reasons of children using these devices today, has been identified as a skill that improves one's learning effectiveness and academic performance. Also, children are known to attribute human like characteristics to these agents, which can boost their interest in learning. We also included parents as our co design partners because they are known to mediate children's technology through various mechanisms, and we wanted to elicit their design requirements and recommendations as well. Therefore, our work was guided by two research questions. How do children think about in home conversational technology that can be used to fulfill their learning needs? And what are the parents' requirements for conversational technology? To this end, we recruited 12 children in the age range of 7 and 12 and conducted co design sessions with an intergenerational group. Three sessions using different techniques of collaborative participatory design methodology were conducted, each comprised of time for snacks, question for the day, the design session itself, and discussion, in that order. The aim of the first session was to elicit children's opinion about using commercially available devices for the purpose of learning. Using stickies, we asked participants to write down their likes, dislikes, and potential design ideas while interacting with Google Home, Amazon Echo, Microsoft Cortana, and Apple Pod. The aim of the second session was to elicit design ideas for future in home conversational technology. At this stage, we were a team of children and the research team. In the second session, we used the techniques of big props and bag of stuff, where the participants acted out scenarios in which they either acted as a device or as a user. The aim of the third session was to refine the ideas we generated in session 2 by including parents' preferences and recommendations. Therefore, we used the layered elaboration technique, wherein parents built on what children had built and they worked collaboratively. Our inductive analysis by affinity diagram led to identification of 25 themes that were clustered into 5 broad categories. The analysis was done on 162 minutes of audio and video data, along with several drawings and low fidelity prototypes developed by both children and parents. These are the 5 categories that were identified during our analysis. Based on the themes, we developed the presented model that depicts the major themes along with the sub-themes and the interrelationships among those themes. For example, the system output on the right allows user to interpret its intelligence, which is shown in the middle. Parental involvement, which you see down below on the right side, mediates children's or users' behavior, which is on the left side of the image. Children included a wide range of output modes, including physical output in form of merit badges. Children also included various modes of learning in their designs, which users could select from. Some of the modes frequently included in children's designs were the following. Instead of simply providing direct answers to users' questions, when children were learning or revising a previously learned topic, one of the modes used scaffolding to help users work out the answers to the queries themselves. Children also included storytelling as one of the learning modes. They included the possibility of practice drills and formative and summative assessments in the form of quizzes and competitive games. In the design session 3, parents came in and said, "We want to generate reports of these assessments." The children conceptualized intelligent technology for learning with a personality and a backstory. In terms of personality, they assigned the devices physical human features such as voices and human anatomy and the ability to move. They assigned intellectual features such as decision making, emotional states. The emotional states could change based on those of users. And they assigned human behavior or human like behavior, which was reflected in various functionalities. The backstory of the personas that they assigned these technology were often based on that of children's favorite media character. We did not restrict children to include only voice as the form of input, and therefore they included a wide range of input modes. However, speech and touch were the most common input modes that children included in their design. Children also interestingly included remote access capabilities. For example, they illustrated how the tablets or the phones that they could carry around could be connected to these in home technologies and they could still access learning modules, for example, but just remotely. Children also enable the user to be able to customize and control devices, functionalities, personas, learning, and input modes. As the children were designing during the co-design sessions, it became apparent that the children expected a high level of intelligence in such technology. The design prototypes manifested intelligence through their human-like conversations. For example, the devices could tailor their communication so that it was more social and just not transactional by developing an understanding of users' context and characteristics, such as mood, intentions, likes or dislikes, and even level of expertise in a given topic. Further, in their designs, the children frequently included the capability to sense the emotional states of its users. For example, irritation, fatigue, sadness. This enabled the devices to adapt their responses and the learning activities it offered to the users. Finally, the children and parents gave devices the ability to activate automatically a learning module and even motivate a user to participate in that activity. While parents did this to ensure that some part of a child's daily or weekly schedule would be dedicated to in home learning activities, the children thought it could help them when they were supposed to practice or revise a topic but they forgot or were not motivated to do so. Designs also illustrated how parents wanted to be involved and wanted to control children's interaction. Parents' involvement and control was manifested in several ways. Parents desired to be able to participate in children's learning activities and they wanted to assume several roles, such as co-learner, motivator, and overseer. For many parents, this was driven by that fear that children's continual interaction with these devices would exacerbate their dependence on technology, which in turn could displace parenting relationships by excluding tasks that would otherwise be considered primarily a parent's responsibility. They also feared that they would just lose behind the fast pacing technology. Parents also designed features that could inform them when children communicated in an unacceptable manner, such as using curse word, and would automatically restrict children. They considered that the device should motivate good social behavior and foster social communication. They felt that these devices would lead children to always be with technology and not interact with anybody in the household. Finally, parents pointed out a lot of privacy concerns, primarily because the data was, after all, about children. Their children were young, and they thought that children would not understand the potential implications of such data collection. They desired that they should know which data collection is happening, when it is happening, and they wanted to be able to turn off data collection and any sort of processing if they so wish. Based on the developed model, I want to leave you with following 4 design recommendations. The future in-home conversational technology that can be used for children's learning purposes should support different learning modes, they should assume different roles, and they should support different personas. They should be able to adapt based on users' context, sense and express emotions, and be able to have a conversation like a human. Based on parents' requirements, these devices should foster social interaction and engagement. Parents should also be able to set learning goals, participate in children's learning activities as a co-learner, as a motivator, or as an overseer, and they should also be able to monitor and restrict usage. Thank you for listening. If you have any questions, you can contact me on the displayed email ID or the Twitter ID.